Hello and welcome back to part 2 of section 2.4 of geometry. Let's now complete the example problems together. Number 1, inductive and deductive reasoning. Determine whether each conclusion is based on inductive or deductive reasoning. Remember, inductive reasoning uses pattern recognition to go from specific to general. Deductive reasoning uses facts and definitions to go from general to specific. So, every time Katie has worn her favorite socks to a softball game, she has gotten at least one hit. Katie is wearing her favorite socks to a game tonight. So, she concludes that she will get at least one hit. This is interesting because there is definitely a pattern noticed here. Katie, every time she wears a socks, she gets a hit. But that is the pattern Katie has already noticed. We're going to use that pattern to apply to a new situation, Katie wearing her socks to tonight's game. That's the specific instance. So the conclusion is she will get at least one hit. You can look at this as a conditional. If Katie wears her favorite socks, then she gets at least one hit. Katie is wearing her favorite socks, therefore she will get at least one hit. That matches one of our deductive reasoning formats, law of detachment. So, for all those reasons above, this is deductive reasoning. Now, B, if John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. This is very similar. Again, based on the prior pattern, what's happened in the past, we have the general statement, if John is late, he will be assessed a late fee. John's payment is late, therefore he will have the late fee. Exact same format. This is deductive reasoning with law of detachment. The way to make these inductive would be if they had given us for the last 3 months, John was late making his payment, and each time he got a late fee. So what is he going to get next? Or if he's late this month, what's going to happen this time? Example 2. Use the law of detachment. Determine whether each conclusion is valid based on the given information. If not, write invalid. Explain your reasoning. Okay. If two angles form a linear pair, then their non-common sides are opposite rays. Two angles form a linear pair, okay, like we have here. Then their non-common sides, the linear pairs by definition will always share at least one side because they have to be adjacent. So the non-common sides, the other side, so this one and this one, if they're a linear pair, will those be opposite rays? That's what this is saying. And then we have this specific sample, AED and AEB form a linear pair. Okay, we have the conditional, the general property, and then the specific example of that hypothesis. If two angles form a linear pair, hey, these ones form a linear pair. Well, then their non-common sides are opposite rays. Oh, so these non-common sides must be opposite rays. Get the specific version of that conclusion as our new conclusion. And let's double check that they have named these correctly. If these are the linear pair of angles, then the rays would be ray ED and ray EB are opposite rays. So then this is valid using Law of detachment. Why? Because it restates the hypothesis and concludes the conclusion. Don't get those mixed up. Restating the conclusion, concluding the hypothesis, no good. Example B, if Mika goes to the beach, she will wear sunscreen. Mika is wearing sunscreen. Conclusion, Mika is at the beach. Do you know that for sure? Here we have the conditional. If Mika goes to the beach. Going to the beach is the hypothesis. Wearing sunscreen is the conclusion. And what have we restated here? Wearing sunscreen. We restated the conclusion. So not valid. Why? Because it restates the conclusion and tries to conclude, but concludes falsely the hypothesis. So that conclusion is false, or at least it's not 100% guaranteed true. For example, maybe she's wearing sunscreen because she's at the pool, not the beach. Example number 3. Judge conclusions using Venn diagrams. Determine whether each conclusion is valid based on the given information. If not, write invalid, explain your reasoning using a Venn diagram. Okay, given. If a primate is an ape, then it does not have a tail. Coco is a primate who does not have a tail. Conclusion, Coco is an ape. Notice all of the categories involved here. We have primates as a category. Apes are a category. Coco is a primate, so that's a specific item inside the category. Having tail, not having a tail, I would say that's another category. I know it's like a property here, but we'll make it a category. Things that have tails or don't have tails. Let's talk about all of the primates. And we have inside the primates, we'll have the apes. You know what? We can write inside the circle here. And if a primate is an ape, then it does not have a tail. So that would have to be a separate group for having a tail. There is no overlap. If you're inside this circle, there is no way you are inside that circle at all. Two totally separate things. Got it. Coco is a primate. Okay, so we need a point labeled Coco somewhere in this box, who does not have a tail, so can't be in this circle. Does that mean Coco is an ape? If you're not in this circle, do you have to be in that circle? No. We'll just put a point here, label Coco. Invalid. Conclusion. If Coco, here is our counterexample, as it were. So that's what the Venn diagram allows us to do, sort the information and visually show a counterexample. I don't need to write anything additionally because the Venn diagram makes that clear. Look. Here is an example of Coco. It meets all the criteria, but it doesn't fit that conclusion. Example number 4. Test example 4. Okay, this is like a standardized test sort of format. Determine which statement follows logically from the given statements. If you like musicals, then you enjoy theater productions. Makes sense. Theater productions, musicals are types of theater productions. If you are an actor, then you enjoy theater productions because you're in them. Okay. So, does that mean if you are an actor, then you like musicals? Not necessarily, no. Those don't go together. You could be in non-musical theater. If you like musicals, then you are an actor. Does that one follow? I don't think so. You know what? Let's actually organize this a little bit better. Let's say if you like musicals, we have that one. Then you enjoy theater productions. That's statement Q. If you're an actor, there's a new statement R. Then you enjoy theater. That's the same. Before, that's also Q. So we have two different ways of getting to statement Q. Different routes leading to enjoying theater productions. So we don't have, I've left the laws up here at the top for reference. The law of syllogism here. Notice we have to repeat one conclusion is the hypothesis of the other. Or the hypothesis one is the conclusion of the other. Not repeat the conclusion twice. This, I don't know if we're going to get anything out of here. If you do not, option C, if you do not enjoy musicals, then you are not an actor. That sounds like they're trying to do some sort of inverse or contrapositive here, but musicals and actors are not directly connected. You can't draw that conclusion either, even the negation of such a connection. We have no idea how these fit together. So really, the only true choice is that there is no valid conclusion here, because I have repeated my conclusion twice. I've not got a hypothesis in one and the conclusion of the other such that I could create a shortcut with the law of syllogism. All right, finally, example 5, apply laws of deductive reasoning. So they're not going to tell us which one to use. We just have to draw a valid conclusion from the given statements if possible. State whether your conclusion was drawn using law of detachment or law of syllogism. If no valid conclusion can be drawn, write no valid conclusion and explain your reasoning. You cannot just give up, oh, I don't see it, therefore there's nothing valid. No, you have to be able to demonstrate that this is the opposite of one of them. They are almost, but definitely not quite one of those laws, as we've seen in some of the prior examples. So here we are given, if you are 16 years old, then you can apply for a driver's license. Okay, you are 16 is a hypothesis. Apply for a driver's license is a conclusion. We could also label these P and Q, check to see what gets duplicated. Nate is 16 years old. Okay, that's a repeat of statement P. Okay, I have a non-conditional restatement, a specific instance of the hypothesis of the conditional. That's good. That means this is law of detachment. So Nate is 16. That means Nate can apply for a driver's license. Never mind that he has to get a learner's permit first. How do we know that's true? By law of detachment. All right, and that finishes the last example. So that concludes section 2-4. Yep, that's it. This concludes section 2-4 of deductive reasoning. So long, farewell. Enjoy the rest of your day.